Okay, we want to find the domain of this rational function. And it's rational because there's x terms in the denominator. So we're going to take the entire expression in the denominator and we're going to solve for not being 0. So 2x squared plus 7x minus 15, and we'll put not equals 0. We're going to solve this for x. And I want to solve this into two binomials, and they'll be linear binomials. 2x squared can be factored into 2x times x. Now 15 has lots of factors. There's 1 times 15, there is a 3 times 5, there's a 5 times 3, and a 15 times 1. Okay, so one of these four are going to work. Let's see, I'm not sure which one first. Let me try the 5 times 3, see if that works. It may not. 5 times 3, this will give us a 5x here, and this will give us 6x. And this tells us on the minus sign here that we need different signs in order to get a 7x. So let me use different signs. Try to get a positive 7x, and different signs here only give me a positive 1x. That's not what we need. So let's start again. And again, 2x times x. Let me try the, that doesn't work. Let me try the 3 times 5. 3 times 5. That'll give me 3x here. That'll give me 10x. And I need different signs. And to get a 7x, yeah, I can use minus plus. I think that'll work, because that does give me positive 7x, and that's what I want, positive 7x. Alright, so I need a minus first, and then a plus. Okay, now I can take these individually as linear equations and solve for x. Okay, so let's start here with this side here. Let's add 3 to both sides. Yeah. Plus 3 plus 3, that gives us a 2x and a positive 3 here. And then we're going to take our 2x not equal to 3 and divide both sides by 2. That'll give us a 1x and a 3 halves. Okay, good. This was a little simpler. I just have to subtract 5 from both sides, and I have a result for x. Okay, so if I put both of these on a number line, let's make a number line here. I'll put my negative 5 there, and I'll put my 3 halves there. And I can't use these, so let's circle these out. So we can't use those values, but we can use everything to the left here for our domain. So we'll say our domain could be negative infinity to negative 5. Our domain can be anything within this area, which is from negative 5 to 3 halves. And our domain can be anything in this area right here, which is from 3 halves to positive infinity. Okay. All right. Oops, sorry, I should have brought that up a little higher. So once again, we're going to omit negative 5 and omit 3 halves. And our domain could be anything in this area. Again, negative infinity to negative 5. Anything in this area right here, which is negative 5 to 3 halves. And we can use any values in this third area right here, which is from 3 halves to positive infinity. Okay, let's try it again for this one. We have a trinomial here in the denominator, so we're going to take the x squared plus 2x minus 15, set that not equal to 0. And we're going to solve here for x by converting this into two binomials. So x squared factors into x times x. 15, again, there's lots of choices. There's this 1 times 15, there's the 3 times 5, there's the 5 times 3, and there's the 15 times 1. Lots of choices. I'm going to go with the 3 times 5. I'll try that and see what happens. So 3 times 5, and that gives me 3x and 5x when I do the inside and outside. I need different signs to get a 2x, so I'll choose negative and positive. That combination does give me a positive 2x, so I got it. So negative first and positive second. Now let's take these binomials and solve them both for 0. X plus 5 equals 0. Okay, and I'm going to add 3 to both sides here. This will give me x cannot be 3. Subtract 5 from both sides here, and I'll get x cannot be -5. Okay, so let's put a number line, and let's put these two numbers here on the number line. So -5 would go first, and then the 3. And so since they cannot be equal, we're going to kind of zero those out and say, hey, we can't use those. So that means any number in this range right here, in this area, can be used for domain. So domain can be this area right here, which is from -infinity to -5. And we can also include this area right here, that second area, that's from -5 to 3. And we can also include this area right here, which is from 3 to +infinity.